This is 7.3. We're going to start talking about the sine and cosine function in a little bit more depth. What we talked about in previous sections, we talked about if we were to put a circle or if we were to use a coordinate plane, we had talked about how our initial ray will always be what is pointing to the right, basically the x-axis to the right, and then everything we do from there is going to create a terminal ray. This is our initial ray. So like right here where you see this R, that would be like our terminal ray, and we will always be measuring what our degrees are from this initial ray to that line. Well, what we can do is we can actually use sine and cosine to talk about this a little bit. We have two formulas here that we probably won't use that often, but it's how our formulas are developed. Is we have the sine of theta is equal to y over r. So in other words, the y is whatever the y value is, and the r is whatever the r value is. The r will always be the hypotenuse of a right triangle that is created. So if I did this, we would have, obviously, this would be our x value, this would be our y value, and then the diagonal is our r value. So sine of theta is just going to be equal to y over r. Okay, cosine of theta is going to be equal to x over r. So now let's take this over to the other picture over here. So you see almost the exact same picture. But now, this is what we call a unit circle. And we are going to be using the unit circle a lot in this class. So the unit circle just means that the radius is always going to be 1. So we're dealing with a radius of 1. So that means this point right here is 1, 0. This point up here is 0, 1. This point over here is negative 1, 0. And then down here is 0, negative 1. Those are just the x and the y values. If the radius is just 1, you can see how our functions transform. Instead of it being y over r, because r is just 1, it's just the sine of theta is equal to y. In other words, sine of theta will always be representative of the y value on a unit circle. And we're going to talk about how that is going to work. So the other thing that we want to discuss is how this is going to work. So we said that this right here is always our initial ray. So if this is our initial ray, then what we would say is that starts us out at 0 degrees. It also starts us at 0 radians because we haven't done anything yet. When we go to this vertical one right here, what we have is we have instead of it being 0 degrees, because we've gone 90 degrees, that would be 90 degrees. And in radians, that is the same as saying pi over 2. Again, you could do the conversion of 90 degrees to radians and you'll get pi over 2. But think of it like this. If the entire circle is 2 pi, then a quarter of the circle is going to be 1/2 pi. We get over here, our degrees are 180 degrees and pi radians. Down here we have 270 degrees and 3 pi over 2 radians. And then at the very end, we have 360 degrees and 2 pi radians. That's the way that our unit circle is going to look. We start at 0 and then we go around in a counterclockwise fashion. And you could keep going. We could say this is then 450 and then keep adding all the way around. So you can keep going around and keep increasing that. But these are basically the values that you're going to use on a regular basis. So how are we going to use this? Well, let's first talk about what we know about our x values and y values. So what I want you to do is I want you to imagine that our sine, we're going to be labeling this in black. Okay, so now however you want to label it on your notes is up to you. But if you think about it, if sine is representative of y values, then that means that in the first quadrant, this first quadrant, that means that all of our sine values are going to be positive because all y values are positive. In the second quadrant, our y values are still positive. So all sine values in the second quadrant are going to still be positive. Then when we get to the bottom two quadrants, because our y values are negative in both of them, all of our sine values in those quadrants will always be negative. In other words, what we're saying is that if I have the sine of an angle that is between 0 and 90, then it's going to be positive. If I have a sine of a value that's between 90 and 180, it's still going to be positive. If I have the sine of a value that's between 180 and 270, it's going to be negative. That's just the way it works because our y values are negative on the bottom and positive on top. Now, if we go to the cosine, cosine is representative of our x values. So if you look at this, our x values in the first quadrant are positive. So therefore, our cosine is going to be positive. our x values in the second quadrant are actually negative. So therefore, our cosine values will always be negative. In the bottom quadrant, our x values are still negative, so that means we're still going to be negative. And when we get to the bottom right quadrant, our x values are positive again, so our cosine will be positive. So you kind of get an idea of, based on which quadrant we're dealing with, however many degrees or radians we're dealing with, you can determine whether your cosine and sine are going to be positive or negative. And that's what we're going to be dealing with a little bit in this section. Okay, so moving on, let's look at an example here. This is real basic stuff at first. So we want to solve sine of theta equals 0. So let's start with the sine of theta equals 0. Now recall, we just got done saying that the sine of theta is equal to our y value. So I want to know, when is my y value equal to 0? Okay, so when is it? So y equals 0 at, and now we look at our unit circle. Our y value is 0 at this point right here. So that means 0 degrees. Okay, it's also 0. Y value is 0 also here, and that's at 180 degrees. And then it's 0 again once we get back to the beginning, which is 360 degrees. In radians, that equals 0 radians, pi radians, and 2 pi radians. So we know that all these values, if we were to plug those in for our theta, those are all theta values that will work. But the thing is as we said, you can actually keep going around in a circle, around and around and around and around. So what we're going to do is, instead of giving specific values, because there's infinite values, we're going to write a real brief expression to say what theta could equal. Theta can actually equal, if we start at 0, and then we're adding 180 after every time, then we can just say that it's 180 times n. N will be any integer. So if n is 0, then 180 times 0 is 0. If n is 1, then 180 times 1 is 180. If we wanted to do a negative, we could. N equals -1 equals -180. All of those will work. So that's our expression in degrees, and then our expression in radians would just be pi times n. Okay, so there's no initial value to add, so we're starting at 0, so we don't need anything to add, and you'll see how that's going to be different in the next one. So these are what the true answers for this problem are, because theta can go on forever and ever. So we have to make sure that we write it as an expression where n can be any integer. Okay, so let's talk about sine of theta equaling 1. Again, it equals y, so we want to know, when is y equal to 1? Well, y is equal to 1 at 90 degrees. Okay, so y is equal to 1 at 90 degrees. Is it equal to 1 at any other place? No, it's not. It's only equal at 90 degrees. Now, we could also say that when we go around a full circle, that it's also going to be equal to 1 at 450 degrees. And then if we do it in radians, we have pi over 2. Okay, so we have pi over 2. And then for our other radian, it would be 2 pi plus pi over 2. Okay, so that means we have 4 pi over 2 plus pi over 2, so we end up with 5 pi over 2. So now when we write our equations here, think about what we're starting with. We're starting at 90. 90 is the first value that we get where it's equal to 1. So that means it's going to be 90 plus, and then basically, how often is it going to be 1? Well, every 360 degrees after that. So it's got to do a full circle, so it's going to be 360 times n. Again, if n was 0, then we get 90. If n is 1, then we get 450. So it works out the same way. And then our radian equation will be exactly the same. Our first value is pi halves, and plus 2 pi times n. So these are our equations for this one. And I know that can be a little bit difficult to understand, but basically what you're looking for is, where are you starting? Where's the first value where our y value is equal to 1, or x value is equal to 1 or 0, whatever they're asking. And then from there, how often will it get back to that point? Okay, so there's one that I want you to do on your own. It's the cosine of theta equals 0. Again, recall that cosine of theta is your x value, so that's going to change a little bit how this works. So let's see if you can do that on your own, answer the question, let's see how you do. So on this one, it's a little bit different because x is going to be equal to 0 at both 90 and 270. So it's very similar to the one we did above, but now instead of it being, obviously our starting points are 90 and pi halves, radians or degrees, but now it's going to be changing, it's going to be 0 every 180 degrees or every pi radians. So it's not 360 because we get 0 at both the top and the bottom, whereas we only got y equals 1 at the top only. So that was a little bit different, but kind of the same concept. So hopefully you got that. Okay, let's flip the paper over. I know this video is probably a little bit longer than what you're used to for this class, but let's get through at least the first two of these. So it says given sine of theta equals 5 over 13 and cosine of theta equals negative 4 over 5, we want to find what the cosine of theta is. Well, the first thing is you're actually needing to give more information here. We need to know that this is going to be a quadrant 1. So this one's going to be quadrant 1. And then this one, the second one, is going to be quadrant 2. So that's going to be important, and I'll explain why. So what are we going to do? So we know that sine of theta equals 5 over 13. Hopefully we recall that the sine of theta is equal to opposite over hypotenuse. So if I were to draw this right triangle, it's a terrible right triangle, but if I were to draw this triangle, and this is my theta, that means that my opposite side is going to have to be 5, and my hypotenuse side is going to be 13. Well, we can figure out what our adjacent side is by doing the Pythagorean theorem. So that's what I'm going to do, is I'm going to do 13 squared equals 5 squared plus a squared. And our a squared is what we're looking for. So when we solve for that, and I'm not going to spend my time doing that, you guys can do the Pythagorean theorem just fine. You get a equals 12. So therefore, we have a is equal to 12. So when we do cosine of theta, which is what we're looking for, cosine of theta is equal to adjacent over hypotenuse, which is going to be 12 over 13. Now, the one thing that we have to pay attention to, this is quadrant 1. Okay? Our 12, or our adjacent side here, that is our x value. If it's in quadrant 1, then that means our 12 is going to be a positive, because it's in the first quadrant. Again, think about a quadrant, think about your x values. What is your x value in the first quadrant? It's positive, so 12 over 13 is our answer here. Okay? Second one, cosine of negative 4 over 5. So here, same idea, but you have to think cosine of theta is adjacent over hypotenuse. So when I draw this triangle, the adjacent side is going to be negative 4. So don't worry about it being a negative right now. It's just because it's in a second quadrant. And then we have our hypotenuse is going to be 5. So we're missing this side right here. We're going to call that A. We know that that's the opposite side, but I'm not going to put an O there. So again, we are going to solve for that missing side. 5 squared equals negative 4 squared plus A squared. And again, I'm not going to go through and do all the solving for you. You're going to find out that A is equal to 3. Once again, we're in the second quadrant. So let's think about where the second quadrant is. It's right here. What our A value in this case is going to be our Y value, okay, because it's the vertical of the triangle. You know, it's just easier to draw all of your triangles with your theta in the bottom left-hand corner. So all of our values here are positive, so A needs to be positive, so 3 is good. So therefore, the sine of theta is going to be opposite, which is 3, over hypotenuse, which is 5. Okay, so what I want you to do is, just in the way to save time, I would like you to try this. Do the best that you can to get this set up on your own. Bring it to class, and that's what we're going to start off class with. So do this on your own, bring it to class, let's see how you do. Again, this is, these are tougher problems, so hopefully you're able to get this. I'll see you then.